Okay, good afternoon, ladies and gentlemen. Welcome to session C2. I will be your host for today's session. I'll read the instruction for today's session. I will just adjust the light first, okay? So the time allocated for each presentation is 10 minutes, and there will be a 3 minutes Q&A session. And the presentation slide will be showed and controlled by our side. So the presenter will only need to say next to move the slide. The remaining time for the parallel session and the Q&A session will be reminded by chat. Will remind the remaining time in 3 minutes, 1 minute, and when the time is up. So there will be 3 reminders. There will be no interruptions during the presentation and Q&A session. In parallel session, attendance will be muted, except when the presenter is doing the presentation and during the Q&A session. Attendance camera will be turned off in parallel, except when he or she presents the presentation and asks answers in the Q&A. When the attendants are willing to ask, the attendants must click the raise hand symbol in the Zoom application before asking in the Q&A session. The session chair will choose the attendants and give them the chance to ask during the Q&A session. There is no time extended in parallel and Q&A session, so please mind the time. Attendance is not allowed to eat and drink during the parallel session and are not allowed to send personal message to session chair or assistant of the session chair. The session chair will remind and stop the attendance when the time is up. Okay, so let's move on to the first presenter, titled Green Warehouse Performance Measurement. No, sorry. Gate-to-Gate Lifecycle Assessment Coal Power Plant in Indonesia by Mr. Mirza Arshad. I will let Mr. Mirza Arshad to start the presentation.
Assalamualaikum warahmatullahi wabarakatuh. Excuse me, before we start, may I request to use my PowerPoint presentation?
Yes, you may.
Benar ini. Good afternoon, everybody. My name is Mirza Arshad from Chemical Engineering Universitas Indonesia and Research Advisor Dr. Setiadi, also from Chemical Engineering Universitas Indonesia. First of all, I would like to say thank you to Mr. Teguh Naraski Zahari as chairman in this session. In this opportunity, I would like to present my paper with title Gate-to-Gate Lifecycle Assessment Coal Power Plant in Indonesia. Research background. Public concern about the climate change caused by increasing greenhouse gases emissions. This is indicated by the current global average temperature, which has risen by 1 degree for the last 10 years. According to the Paris Agreement, in order to use, these emissions should be no more than 400 that cost exit rate. So considering in the implementation of LCA. Next slide. Let me show you Indonesia energy mix. Based on data from Indonesia Electricity Supply Business Plan or RUPTL, show that the coal has largest role in Indonesia energy mix in 2019, around 67%. For the next decade, coal will be still has the largest role in Indonesia energy mix, around 55%. Research problem. First, how is the LCA methodology should be implemented on coal power plants to assess the environmental impact of electric energy generation? Second, how much the impact due to source of energy usage from coal combustion which produces CO2 and SO2 emissions? Scope of work. The scope of work in this research are the research is only focused on CO2 and SO2 emissions. And research, the research object is one of the coal power plant in Indonesia. And the third is the power plant use medium calorific value. Fourth, the research use gate-to-gate system LCA using CIMAPRO 9.0. Research goal to obtain the amount of emission CO2 and SO2 generated from the coal power plant and global warming potential acidification potential data from coal power plant on parameter of CO2 equivalent per gigawatt hour and ton SO2 equivalent per gigawatt hour. This is a state of the art. The research about LCA of coal-fired power plant has conducted worldwide. In the last 5 years, the similar in LCA coal-fired power plant research has collected the result about global warming potential value as shown below. For example, in the United States, the LCA coal-fired power plant research has resulted global warming potential of 888 ton CO2 equivalent per gigawatt hour. Next is global action to deal with the climate change. Start with United Nations Framework Convention on Climate Change in 1992, commit to reduce greenhouse gases in the atmosphere. And the next in Kyoto Protocol, commit to reduce greenhouse gases for 7% in 2012. And the last is Paris Agreement. Commit to withstand Earth temperature increase no more than 1.5 degrees Celsius. The release emission should be no more than 490 gigaton CO2 equivalent per year. Life cycle assessment. Life cycle assessment is one of the environmental assessment methods regarding the implementation of the environment. The LCA method is divided into 4 main steps. Step 1, goal and scope definition. Clearly define the objective and scope of the research, including selecting functional units. Step 2, life cycle inventory, compiling an inventory of relevant energy and material inputs and environmental releases. Step 3, life cycle impact analysis, evaluating the potential environmental impact associated with identified input and release. And the last step, interpretation, interpreting the result to help decision makers.
Mr. Mirza, your time is 3 minutes.
Okay, LCA system boundary impact. LCA evaluate the impact of products throughout the lifetime. Sorry. There are several types of system boundary: cradle to grave, cradle to gate, gate to gate. This is LCA research step. Step 1 is goal and scope definition. Start with Paris Agreement. Research goal is obtain global warming potential and acidification potential, and with unit function CO2 and SO2. And then step 2, life cycle inventory, life cycle impact assessment, and the next, the last step is interpretation. This is a life cycle impact assessment result. The research impact assessment result calculated by CIMA-Pro 9.0, the impact assessment using Europe Impact Assessment Standard called CML 2001 that developed by Leiden University, Netherlands. The result from this research, global warming 800 ton CO2 equivalent per gigawatt hour. Potential is 0.6 ton SO2 equivalent per gigawatt hour. Conclusion, the LCA calculation for the parameter global warming potential result is 800 CO2 equivalent per gigawatt hour, and acidification potential result is 0.6 ton SO2 equivalent per gigawatt hour. The result of global warming potential.
Time is 1 minute.
Sorry. The result of global warming potential is lower than China and Turkey. However, comparing it with, sorry. Yeah. Sorry. The result for acidification potential is higher than China, however, lower than Turkey and USA. Thank you, Mr. Teguh Narasi.
Okay, thank you, Mr. Mirza, for the presentation.
Yes.
And now let's move on to the Q&A session. Is there any questions from other participant?
Yes, Mr. Yes.
Yes, please.
Yes. I want to ask you, Mr. Mirza Arsyad, that what parameters that affect life cycle impact analysis result?
Okay. The first one is fuel specification. In this case, specification of coal is different among low, middle, and high calorie. So even in the same calorie value, but another parameter must be different. The second is coal quantity, and the last is plant efficiency. Lower efficiency will make coal consumption is higher. That is my answer.
Okay, thank you for your explanation.
Thank you.
Thank you for the question and the answer.
Thank you.
Is there any question from the participant? Ask Mr. Mirza.
Yes.
In your policy recommendation, you said that there should be a sustainable policy that consists of technological development, which will optimize environmental benefits. So what kind of sustainable policy do you suggest?
Thank you, Mr. Teguh. I suggest that, sorry. I suggest that with co-firing with biomass, for example, we can reduce energy consumption. We've used the new technology on co-firing with biomass with carbon capture storage technology. Yes.
Okay. So I agree with your answer. I believe the time is up for the Q&A session. So thank you, Mr. Mirza, for the presentation and the answers. So let's move on to the second presentation entitled Process Safety Management and Reliability for Compressor Inspection Using Big Data Analytic, will be presented by Ms. Sarah Solihatul Amalia. To Ms. Sarah, I let you start the presentation. Sorry, Mr. Mirza, can you turn off the presentation so we can start the presentation for the next session, next presentation. Stop screen sharing. Okay, thank you. Yes. No, I mean stop screen sharing.
Okay. Wait a moment.
Okay. Thank you. Okay. Ms. Sarah, I'll let you start.
Okay. Thank you very much for the opportunity. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Sarah Solihatul Amalia for ID 79 with Mr. Andi Nur Saman Someng. I want to present my paper titled Process Safety Management and Reliability for Compressor Inspection using Big Data Analytic for a conceptual study. Okay, next slide, please. Okay, here's the presentation outline. My presentation consists of 6 parts. First, abstract, and then introduction, and then literature review, data analysis, result, and conclusion. Okay, let's jump to abstract first. Okay, we see here potential hazard is related to leak prevention, and then oil spill, and then monitoring of equipment damage, excess temperature, corrosion, etc. And then to prevent potential hazard, we need to implement the process safety management. And then based on our research, we found that the mechanical integrity is the most critical element in process safety management that have to be focused. We use historical data, historical of failure data, and maintenance of reciprocating compressor that include structure and unstructured data from 2014 until 2019 to identify the damage pattern damage pattern and reliability rate of the compressor itself. And then by using Webull analysis, our software, we can conclude that it will be more useful to use preventive maintenance as the first barrier from getting failed. The keywords are compressor, maintenance, reliability, risk management, big data, and our software. Okay, next slide, please. Okay, next for introduction. And then we see here oil and gas refinery process is related to operational and business growth, which operational is related to productivity and risk management, and business growth is related to research and development and marketing. In this paper, we focus in risk management to prevent potential hazard. Including loss of life, endangering the health and environmental damage, and loss of primary containment or LPC in process area. And then process safety events log sheet is recorded through the process safety management program that it will becomes an industry requirement to prevent major event. Sorry. Okay, thank you. Okay, next. And then for the current condition, we see that the topic of big data management related to process safety hasn't been encountered yet. Because of the heterogeneous field data that feels difficult for decision making. And then we analyze data based on model to see the failure pattern in mechanical integrity, especially with big data analytic R software by focusing in compressor reliability. Yeah, next slide, please. Okay, then for regulatory review, first, we see here the correlation between each element. Here we see the mechanical integrity is related to many element like PSE, process hazard analysis, operating procedure, which is indicates to process oil and gas. And then so we focus in process safety, we focus in mechanical integrity to solve existing problem that have large heterogeneous data to determine the reliability rate for the critical compressor. Okay, next please. Okay, here big data analytic, there's 4 steps to analyze data with big data. First, database. It can be historical of maintenance from equipment. In this case, we use historical data of maintenance compressor, and then descriptive analytic. We change the data into readable information such as graph and histogram, and then his diagnostic analytic. We calculate the parameter of the equipment, and last is predictive analytic. This step will predict what will happen in the future. And then next slide, please. Okay, this is a Webull distribution. There are equation of reliability without preventive maintenance and with preventive maintenance. The Webull use several basic parameters, like here we see beta and theta. beta is correspond to failure rate, and the theta is correspond to mean time to failure. And then next slide, please. Okay. Okay. Next, data analysis. The concept of analysis method in this paper consists of four steps. First, filtering data. Here we have unstructured and structured data. Then we separate them all, and we did load package and then function dataset for pre-processing analysis. And then next, visualizing data. We see the pattern of failure by using Pareto analysis in the graph. And then next, standardizing data. We fit model and estimate some parameter like beta and theta, like I've been explained before. And then evaluating data. We plot failure rate and reliability function to compare the reliability rate without preventive maintenance and using preventive maintenance. All the graph will be presented in our software. Okay, next please. Okay, here we use Pareto analysis to determine which compressor that are critical. And then we see in the graph here that compressor A, C, and L are the most critical and the most critical compressor that have a higher number of maintenance of failure. And then compressor A, C, and L will be analyzed using to diagnostic analytic by using our software. Okay, next. Okay, for the result, by using syntax, we see the graph here that all of compressor are suitable to use Weibull distribution because of the regression is high. And then we see the beta parameter, shape parameter, that compressor A is higher than another, which is 1.248. So we are focusing in compressor A to analyze the reliability rate without preventive maintenance and with preventive maintenance. Okay, next. Okay, we see here the reliability rate of using preventive maintenance is higher than without preventive maintenance. So preventive maintenance before failure occur is far more cost efficient than waiting for potential consequences to failure to produce output. And then next.
Time is 1 minute.
Okay, the conclusion. From this research, you can conclude that big data analytic can make database, descriptive analytic, diagnostic analytic, and predictive analytic. And then using Weibull distribution, we can verify that the preventive maintenance is required to prevent the critical compressor from getting failed during operation. And as it was proven on the graph on the compressor A, that reliability rate with PM is slightly higher than without PM. Okay, that's all for me. Thank you very much.
Okay, thank you, Ms. Sarah, for the presentation. Let's move on to the Q&A session. Is there any question from the audience, from the other presenters?
From me?
Yes, please.
Mr.
Mirza.
Okay. Thank you, Sarah. I want to use one of your last slide. Based on graph in your slide, we see that the reliability with preventive maintenance is higher. How does it occur? And what parameter that impact the reliability with PM is higher than without PM? Thank you.
Okay. Okay. Thank you for your question, Mr. Mirza. And can we jump to slide Weibull distribution, please?
Which slide again?
In literature review.
Literature review.
Okay, okay. Next. Okay, here. We see here in the equation of reliability with preventive maintenance here. We see that there is other parameters like N and T in capital. That N means the number of maintenance at certain number of time, and T means the time when reliability of the compressor in 90%. That become the baseline. It was assumed, and the requirement of N and C is shown here, and then we see on the graph in the result. Okay. We see here from the graph that the reliability is going down until 0.9 or 90%, and then it will impact. So N parameter N will be raising, and then it will be raise the reliability rate too. But when as the time increase, it was slowly downing the reliability rate instead of the reliability rate without preventive maintenance. Okay, that's all. How, Mr. Mirza?
Yeah. Thank you, Mr. Sarah. Thank you, Sarah.
Okay.
Okay, thank you, Ms. Sarah, for the answer, and Mr. Mirza for the question. So since the time is up, so let's move on to the next presentation.
Okay.
Thank you, Ms. Sarah.
Yeah, thank you very much.
Okay, so for the third presentation, titled Integration of Geographic Information System and Optimization Technologies for the Effective Control of Insert and Main Verification, will be presented by Mr. Fidi Agung Pragastia.
Yeah.
Yes, please, Mr. Fidi. I will let you start the presentation.
Okay, thanks for the opportunity. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. And I will try to present my research entitled Integration of Geographic Information System and Optimization Technologies for Effective Control of Insert and Main Verification. Next.
I'm sorry, Mr. Fidi. Can you please increase your voice because it is not clear? Okay. Okay. Please continue.
Okay. Next. I will start with abstract. Intelligence of technology and information is the right thing to provide accurate information. The role of geographic information system technology has begun to unleash in our field, one of which is in oil palm plantation. The use of geographic information system is very helpful and has a very important starting from the management of the garden, knowing the potential of the land, to monitoring the development, planning the garden, and verification of oil palm. In oil palm plantation, important crop conditions are considered, including the numbers of plant and the level of plant density in one block. If the number of plant and the level of plant density in the block do not meet the standards, then the potential of production is not optimal. For palm oil plantation, include as early as possible, so that the distance of row of plants inserted by early palm oil to life are not far away. Next, please. Management optimization can be done in various ways. One of them is called precision agriculture. Precision farming is a technique that links the application of input and output to plant according to their needs. Management of oil palm plantation to date is based on blocks. Each block is consisting of one planting edge with the smallest unit of 12 and 30 hectares per block. The precision agriculture that can be carried out in oil palm plantation varieties greatly from data collection, both plant data, grow, nutrient, condition, plant health, and production, as well as soil and environment condition, soil, nutrients, fertilizer application, climatic condition. Next. Insertion in oil palm plant can be done through the fresh fruit buds or TBS period H1, H2, or N 3 years. For the purpose of insertion, it is advisable to provide seedlings that are ready for planting. 5-7% of the plant population, but the insertion activities are carried out. Pure inventory activities must be carried out to determine number and
But is there any possibility
to be replaced? But the problem that occurs in the inventory process is calculation done manually. The counters must record directly every tree in its block. This process takes a long time and large area with hilly topography. Problems related to oil palm management usually come in terms and difficulties in managing and monitoring their property. Commercial oil palm plantation can cover many hectares of palm oil. There will be variation in palm oil this year. It will be a problem to store information and data about palm oil partly because this will cause difficulties in monitoring plantation. The almost impossible task is to monitor palm oil manually. Monitor single palm trees will require a lot of time, and without having good management of palm oil, it will affect the development of palm plantation. Next. Next, please. Yeah, the research activity will be carried out in Timang Langsa, in Aceh, Nangro Aceh Darussalam. Total occupation area is 1,241.73 hectares. The total area in plantation is very large, which will cause the difficulties such as hilly topography if it has been handled manually. This plantation is full palm oil plantation management by timbang langsa property. The data collection
Our
use
time is 3 minutes.
the data collection is use drone. The drone used is DJI Phantom 4 Pro, and the software used in this research is Google Earth, Global Mapper, ArcMap, MapSource, DJI Phantom Go, Agisoft Photoscan Professional, Econition Developer, GIM, and for the web-based programming language using PHP and MySQL database. For the Android application, use Global Mapper Mobile. Next, please. Next. Okay. This research was carried out through several stages, namely the preparatory stage. With this stage, prepare we need to do when doing a job. One of them was in the insert and main verification activities, including sub-block maps and flat plane for the drone flat plane, data collection, and data processing stage. Next. The result is showed in the actual situation is in updating 1 and updating 2 based on plan data in 2016 and 17. Survey data are processed using digital image processing and presented in the form of web-based information system. Next, please. Next. Yeah, we can see in the picture, after the image processing is done, the image and that plan will be marked with a red dot, and the gray dot is a fine good plan, and the red dot contains the coordinate data. The data on the number of plan that will die or damage will be used as a reference for the preparation of the number of seedling. Next. To facilitate, the instruction officer will performing maintenance this spam list or instruction can use Android-based application. This application is integrated with GPS, so it helps in seeing the blank spot on the survey result. The officer will do the instruction with the help of design application. Next. The result of
Your time is 1 minute.
The result of this design can be used as a tool is the decision making process as to maintain the sustainability of the number of productive oil palms, so that crop productivity is in accordance with established standards. The use of information system and Android application that will be designed in the process of maintaining and inserting damaged palm oil palms makes working method of plantation more effective, efficient, and save costs due to the proper data processing. The weakness of the system designer are in the process of making data is dependent on the waiter to the good digital image quality. For scan development, the system can be used in real time. Okay, thank you, and I'm ready for the next session.
Okay, thank you, Mr. Fidi. Is there any questions from the other presenters? Okay, so I will ask you a question, Mr. Fidi. What was the most challenging part of your research?
Most challenging part is the data collection. It's very difficult to take a photo from the topography. It's very highly, and the slope of the plantation is very tilted, and the weather, if the weather is cloudy or rain, it is very difficult to take image from the drone.
And how did you overcome those challenges?
I can detect data during the day, the noon, and it will take a very long day, very.
I'm sorry, Mr. Fidi, the time is up, so it's okay. Thank you for the presentation and your answer to my question. Next, we will move on to the fourth presentation. Thank you, Mr. Fidi. And the fourth presentation is titled Analytical Hierarchy Process Method to Engineering Company Selection for remaining life assessment of oil and gas equipment and installation in Indonesia. The presenter will be Mr. Mahfuz Ashari. Mr. Mahfuz, I will let you start the presentation. Mr. Mahfuz, could you unmute?
Okay. Thank you, Mr. Teguh. APCORISE 2020 Committee and participant, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Best wishes. My name is Mahfuz Ashari from University of Indonesia. I will present the paper with title Selection for Remaining Life Assessment of Oil and Gas Equipment and Installation in Indonesia. Okay, next. The content of our presentation is first introduction, oil and gas activities, background. The fourth is research problem and objective, method and conclusion. Okay, next. Introduction. In this section, I will present two main things. That's mining process in outline. That oil and gas mining is a series of activities to find proven reserves of oil and gas natural gas starting from mining, processing, utilization, and sale. Mining activities are carried to lift oil and gas from rock fire to the bubble of the earth, which are then processed into energy source and the main element of the manufacturing process, such as petrochemical. In the second is how important it is to know the mechanism of degradation and the pattern of equipment maintenance and installation. Okay, next. Okay, oil and gas activities. Refer to Indonesian law number 2 of 2001 concerning oil and gas. Mining activity includes upstream business activity and downstream business activity. Upstream business activity consists of exploration and exploitation, and downstream business activity consists of process, transportation, storage, and commerce. Exploration, this means a series of activities to obtain information on geological condition with the aim of finding or obtaining estimates of oil and gas reserve in certain area. And then detail of process are in our slides. Okay, next. Okay, background. Oil and gas mining is a series of activities to find proven reserve of oil and natural gas. Equipment and installation are important components in the exploration and exploitation business. The existence of equipment and installation must provide guarantee. The first, guarantee of safety. This means oil and gas producer will carry out analysis and evaluation to show and understand how the timing and aging process will affect health, safety, and environment. Facility barriers, including operational and organizational technical aspect and resource exploitation. And the second is operational aspect. In the oil and gas industry, most of operations are important and must be planned in advance. The goal of supply chain management is to provide maximum customer service at the lowest possible cost. This is very mandatory. The third is to fulfill regulation ESDM Ministerial Regulation number 18, 2018, that Article 23, verse 1, that installation and or equipment that have exceeded the design lifespan, as referred to in Article 17, may continue to be used after evaluating and the remaining service life and are declared to have extended service life. And the second is Article 25, installation and or equipment that do not have technical document and or are not known for the design life of the service can only be given an increase in service life if the design has been the engineering and remaining life assessment. Okay, next. Okay, the research problem and objective. Based on the current actual condition, the selection of the engineering agency for the assessment of the remaining service life of the equipment and installation is prioritizing the lowest price critically given. Discuss the implementation of a user or main contractor often experience technical and non-technical obstacle in the submission of report. This has resulted in not fulfilling aspect of complying with law and regulation on oil and gas safety system. Okay, next. The objective, the first is determining criteria of remaining life assessment of the equipment and installation of oil and gas. The second, determine the weight of the hierarchy. And the third, determine engineering companies that can meet predetermined criteria. Okay. Method of the research is the first, journal completion, and then expert validation, pairwise, rating, HP analysis, and conclusion. Okay, next. Journal completion and pairwise. Data collection method is done by comparing a matrix from several journals that are used as a reference. For version, the preparation of the hierarchy international journal is as shown. Based on the compilation of journals that have been carried out, the following data is obtained. The reliability criteria, price criteria, availability criteria, health, safety, environment criteria, responsiveness criteria, and quality criteria. The written numbers show the journal number according to the reference. Okay, next. Okay, expert validation. The result of the journal completion are then validated by experts. Validation is carried by the representative from academics, association, inspection service companies, and oil and gas companies in Indonesia. The expert appointed are people who have a scientific and technical understanding of the oil and gas processing activities. Experience in the field of oil and understanding of law and regulation is also a priority in the selection of selected experts. The goal is selection of engineering company. And the criteria, we have 6 criteria: reliability, price, HSA, responsiveness, quality, and availability. Then we have sub-criteria from each of criteria, and we have 3 alternative, company A, company B, and company C. Okay, next.
Time is 3 minutes.
Okay, thank you, Mr. Rating. Data processing using the EHP method with expert choice software, and based on data processing, obtain data as follow: that price have which the first rank for which, and there three, and the second is quality, and the third responsiveness, and the fourth availability, reliability, and then safety. Okay, next. Based on EHB analysis, performance graphs as the figure below show the advantage of each company. However, for PTA, values are far superior to PTB and PTC. And based on the graph, it can be seen that according to the user, PTA has strength in responsiveness but needs improved safety and quality. PTB has advantage of safety but need advantage in quality but need to improve responsiveness. And the result of alternative PTA have first priority to appoint as a company as a assessment. Okay, next. Conclusion. The result of data processing found that price is the main criteria in selecting engineering companies for the assessment of the remaining service life of oil and gas equipment installation in Indonesia. The next section is quality, responsiveness, availability, reliability, and safety. The sub-criteria for cost are resources, personnel, and tools, and payment methods. Effectiveness and efficiency of work implementation is the key to determining the cost of a work to be performed. Engineering companies that are able to manage work pattern will certainly be able to provide the best price to user. In addition to the ability to manage works, the ease of payment pattern also contributes to the assessment of the weight of this cost criteria. The development of financial technology also has a significant impact on the smooth running of business process. Okay, thank you, Mr. Tatu. This is a reference.
Okay.
Okay.
Thank you, Mr. Mahfud, for the presentation. Now let's move on to the question and answer session. Is there any question from the other participants? Okay, Mr. Pandu.
Thank you, Mr. Naraski. Pak Mahfud.
Yes.
Yeah, I just quite surprised with this conclusion that you made, that price is become the main concern when you are selecting this engineering company, especially for the life assessment, for the remaining life assessment. Is there any other reason than based on the? I mean, what was the basic decision behind this result? I mean, I know that you are using the AHP to come to this conclusion, but is there any in real life? Is it really is the case?
Yes, it's really the case.
Yeah, I mean that I understand that if you are selecting this for the trading, for the buying a valve, buying like a compressor, but it should be that you put some kind of more weight on this other component like a safety or reliability or quality instead of the price. I mean, I wonder why you come to this conclusion.
Okay, thank you, Mr. Pandu. That this research is for remaining life assessment, not validation or certification of equipment. Which means based on data and result of inspection, and then the company will assess based on data, not physical assessment.
Okay. Is that the case? Okay.
Okay, sir. Thank you, Mr. Pandu.
Okay, thank you, Mr. Pandu, for the question and Mr. Mahfud for the answer.
Okay,
Is there any other question from the other participant? No, so I believe we still have one more question. So I will ask Mr. Mahfud. In your research background, you state that the low price, when we prioritize low price, sometimes compliance is unfulfilled. However, the result shows that the price is still the main priority. So how do you make sure that compliance will still be met, even though the engineering company with a lowest price is selected?
Okay, thank you, Mr. Naras. Thank you. Our basic research is really the choice of the engineering company is based on experience is so many lowest price, but they are not see the other parameter, which this should be have the other parameter beside lower price. They have should be have so many commitment of responsiveness, ability, quality of results, and the safety. So, okay, Mr. Robert.
Okay, thank you for the answer, Mr. Mahfud. I believe we have come to the end of the fourth presentation. Thank you for your time, Mr. Mahfud. Now let's move on to the last presentation of this session, and certainly not the least. The last presentation is titled Developing a Sustainable Financing Model for Geothermal Projects, a Conceptual Framework, will be presented by Ms. Marmelia P. Dewi. To Ms. Marmelia, I let you start the presentation.
Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore semuanya. First of all, I would like to express my gratitude to the whole committee of APCORISE 2020. Secondly, to Mr. Teguh Naraski Zahari as today's session moderator for giving me the opportunity to share the idea of my research. The last but not the least, to all my colleague presenters who have been extremely amazing on presenting the, each individual very interesting topic. Okay, I'm not going to take further time. I'm going to present my idea. Like it's been mentioned before by the moderator, today I would like to share the idea how to develop a sustainable financing model for geothermal projects, a conceptual framework based on my observation. Okay, next. Okay, the idea of select, the why basically I'm selecting this this idea is just because I've seen that Indonesia has the largest geothermal potential in the world, which is 40% of the global geothermal resources, which is equivalent to 27 to 29 gigawatt, is located in Indonesia. And you might even see that in the map on the right side, which is not one-sided claim. And you can see in Asia, we have like 45 megawatt equivalent, which is 2/3 out of that comes from Indonesia. So among the top geothermal country which is released by end of 2019 by sustained geoenergy, Indonesia is number second. We just like slightly less than United States. So why is it so important? Because geothermal has to be seen as an alternative energy, because it is very friendly environmentally and sustainable, which is, we might say, it has the ability to produce electricity equivalent to the coal-based power plant. Indirectly, I might say the intermittency, which is always be a problem, I mean, mostly a problem from other renewable energy, is very rare to be experienced if we have the power plant sources by from the geothermal. Sorry. Next, development of geothermal in Indonesia basically started based on started lastly from 1974, which is at that time presidential decree stated to appoint Pertamina basically to conduct the exploration and operation of the geothermal field. That one further elaborated on 1981 through the presidential decree number 22 and number 23, which is Pertamina will be appointed or authorized as a single authority to develop a geothermal field, and PLN, in the other hand, will be appointed as a sole authority to distribute the electricity supply in Indonesia. Those then further elaborated on 1991 through the presidential decree number 45 and number 49, which is it allowed Pertamina to basically form a partnership to build and operate geothermal power plants, and also promulgated to provide economic incentive to support the growth of geothermal. So currently, based on National Energy Policy of 2014, we can see that the energy mix targeted by 2025, new renewable energy, it has to be 23% out of the total energy mix. For the long term, it will increase by 31%. So specifically, we can see on the table 1, which is geothermal, is targeted to contribute 7,241.5 megawatt by 2025, and it will increase to 17,000 megawatt by 2050. Next. So before we go further, I would like to draw an attention a little bit about this life cycle of a geothermal project. Geothermal project basically is a quite long written projects, because you might see it's staging from preliminary survey to the commissioning, which lasts minimum 5 years. So each part, it has its own critical success factor, which not be similar to the other phase. Achieving the economic viability of a geothermal project requires a large cost control. That's stated by Moya on 2018. Those give us something, a risk, and that we have to really consider toward development period. So if you see those things, so approximately around 5.2 million per megawatt, it's needed to develop a power plant. I mean, a complete power plant from the survey to the commercialization. Next. As I mentioned earlier on the previous slide, it's quite expensive to build one power plant. It's around $5.2 million per megawatt. So that's give us some barriers. And therefore, I would like to draw what is the barriers and how would be the performance of the geothermal projects in Indonesia so far. Well, basically I break down into three major criteria from financial, technology, and regulatory and policy. The financial, you might say that it's no guarantor on exploration stage at this time in Indonesia. And we have uncertainty on pricing negotiation with the off-taker, because as you might know, the off-taker for the electricity is only
3
one.
minutes.
And we have also lack access to low interest. So from the all three, we might say that we have the uncertainty towards development of the geothermal project. So it goes to all the way, it gives us the character of high investment cost per megawatt, and the return is not visible. Okay, next. This is the map, basically the relationship between uncertainty, risk, and cost. So toward these figures that we can see, the first stage, the first two stage, it might be like less money, less cost, but the uncertainty is really, really high. So over the time, it will be less on the risk, but the price is really high. Okay, next. So I would like, then I know that the geothermal basically having a very, very uncertain nature, which we can classify as a deep uncertainty. So then I would like to, based on my observation, to a solid ground of theory, which is basically based on Mr. Walker work, which is the typology of uncertainty, which from the system perspective. So it will be divided based on the nature, the location, and the level of uncertainty. Based on this map, the figures, then we know that basically geothermal project is having a very deep uncertain nature. Next. So then how to overcome that? So Geringer et al. In 2012 mentioned
Time is
about
1 minute.
that geothermal power generation basically represents significant long-term capital and operating commitment. So that need a sustainable financing. Next. So based on that, we try to divide basically uncertainty and sustainable financing, which is then we find out that it might be overcome by the approach which I call ESDMA and EFMA, which is basically is hybrid method between system dynamic and the EMA, and also the real option and the EMMA. So based on that, what I'm going to do is I'm going to, first of all, to run the system dynamic, which is, this is the staging, how to validate until the experimentation. Next. Also the same thing with the real option. So I would draw from the uncertainty analysis to the present value estimation. At the end, we are going to run it together with the EMA, which is, it gives more what if scenario. So we know exactly what will be the best scenario to give the best decision. Okay, next.
I'm sorry, so the time is already up. So for the remaining presentation, let's just move on to the Q&A. So if there's any question, we'll explore the research on the Q&A session. Is there any questions from the other participants? Yes, Mr. Pandu?
Yes, thank you, Ms. Narowski. Mbak Lia, can you put more, elaborate more on this EFMA method that you are using? That you say that it's a hybrid method combining with the system dynamic.
Yeah, okay. Okay, thank you so much, Mas Pandu. Maybe we missed the slide, which is the best slide to explain. It's in the slide 13 after slide 12. Would it be possible, Mr. Teguh, to point it out to slide number 13? Yeah, yes. This one. Yeah. So basically what we are going to do is, I'm taking the financial modeling with the real option first. So then what I have to do is divining the cost structure And then after defining the cost structure of the geothermal project as a whole, then I'm going to identify critical cost factor and set the performance indicator. And after that, we will calculate the project value. And after having the project value, it goes all the way, come to the calculation of option value of the project for each option. Those will give us the present value of the option. So to get the best robustness and also attractiveness, because sustainable has to consist these two elements, robust and attractive. So we run it through a modeling system, which is, we call it EAMA. And we plan to use Python as the language operating simulation system. So maybe that's explain how we are going to run that, Mr. Pandu.
Okay, thanks, Mbak. No more question.
Okay, thank you, Mr. Pandu, for the question. Next, Mr. Mirza, I believe you have something to ask.
Thank you, Mr. Teguh. I want to ask about the slide relationship between barriers and performance. Mrs. Dewi. Slide number 2, maybe.
Slide number 5.
Oh, number 5, yeah. Sorry.
Yeah, slide number 5.
At the financial, that is uncertainty on pricing negotiation with off-taker. What do you mean this?
Okay. Okay, thank you so much, Mr. Mirza. And it's really, really interesting question. So uncertainty on pricing negotiation with off-taker is based on some other works which is released by JICA and also World Bank. We find it out that many of IPP basically having, you know, if you might, or I mean, I would like to draw back a little bit how we get the WKP or working area for the geothermal. So basically with the current regime, the WKP or the working area basically is auction, right? So after auction, then we are going to proceed further with the PPA or power purchase agreement. So that power purchase agreement between the two parties, basically between the IPP or independent power producer and the off-taker. So this one takes some time. So this is also not one-sided claim by those agencies, but also can be seen further in Buku Pintar of EBTKE, Panas Bumi, which mention a lot of WKP are having a prolonged negotiation toward the pricing. Therefore, the PPA is not signed yet until now. That's maybe explain your question, Mr. Mirza.
Okay, thank you, Mr. Devi.
Thank you so much, Mr. Mirza.
Okay, thank you, Mr. Mirza, for the question, and Ms. Marmelia Dewi for the answers. So I think that wraps up the 5th presentation from Ms. Marmelia Dewi. Thank you for your time. And now let me just summarize what we had today. So we had 5 presentations. The first presentation by Mr. Mirza discussed the life cycle assessment of coal power plant in Indonesia. And the second was process safety management and reliability for compressor inspection using big data analytics. The third was integration of GIS and optimization technologies for the effective control of insert and main verification. And the fourth was AHP method for selecting engineering companies for remaining life assessment. And lastly, we had Ms. Marmelia Dewi developing a sustainable financing model for geothermal projects. Thank you for all the presenters. All papers are equally interesting, and I hope that this research can be further moved forward and to address some limitations. And for now, let's take a group photo. So I will ask each one of you to turn on your camera, please. If you would just turn on the cameras. Okay. So Mr. Fidi, Mr. Pandu, Mr. Gagat, if you will, and also Ms. Marmelia Dewi. Okay. Mr. Fidi, if you would join us. Mr. Andi Setiawan, thank you for joining. Okay, so let's take the picture. 1, 2, 3. Big smile. And for you, for your companies, and for your field of research. On behalf of the committee, I would thank you for joining APCORISE 2020, and I bid you farewell. Stay safe, stay healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.